Hi, this is Mr. Anderson, and today we're looking at what makes one atom different from another. So I'm sure we've all seen at some point a picture of a periodic table, and what I have on the screen is one box from the periodic table. There are around 118 of these elements on our periodic table. Most of them are found in nature. There are a few that have been made in a laboratory. But out of all these atoms, there are a couple things they have in common. So we're going to start learning how to read the periodic table to figure out what makes one atom different from another. And we are going to focus today on just part of the answer. We're going to focus on this first number in the box of an element. The smallest number, and it doesn't matter. There are different designs to the periodic table. It doesn't matter where this number is, this 6. It could be on the side, the 12 and a 6 could be switched. It doesn't really matter. The lowest number in a periodic table box is always the atomic number. So let's move over here a label. It tells us this is the atomic number. And this number is really important. This number is the identity of an atom. We can think of it kind of like their badge when they go to work. This number never changes. Any carbon atom has to have an atomic number of 6. It's its identity. And this atomic number tells us the number of protons that make up the atom. So every carbon atom always has 6 protons. The number of electrons could change, the number of neutrons could change in a reaction, but the number of protons never changes. It always stays the same. So the number of protons, if you're a carbon atom, is always 6. And remember, these protons have a positive charge. So, we know that every atom on a periodic table has an atomic number. It's always the smallest number in the box. That number never changes for that atom. For carbon, it's 6, and it tells us that there are 6 protons for a carbon atom. When we look at this box, we also see this symbol here. We should mention that symbols only come in 2 forms. One form is with a capital letter, like this one. The other way these symbols come are with a capital letter and one lowercase letter. There are a few that are made in the lab setting that come with a capital and 2 lowercase letters. Right? But all the atoms we're going to deal with in class either have a single capital letter or a capital and a lowercase. Now in this case, carbon's kind of easy because C, carbon, seems logical. Right? There are some that aren't so logical, and the reason is because some of these names come from Latin. So if you're looking for something like gold, right? Gold on the periodic table comes from the Latin name of Aurelius. It's AU. So you're not going to find a capital G or a GO for gold on the periodic table. Right? Okay, so there's one more piece we need to talk about today. With these boxes on the periodic table, there's more than one piece of information behind a number. And so this 6 here tells us more than just the number of protons. Every atom on a periodic table is neutral. And what that means is that the charges that make up the atom are balanced. So if there are 6 positive charges to make up an atom, in this case carbon, there also have to be 6 negative charges to balance it out. And if you recall, the negative charges of an atom are made up of electrons. So if there are 6 positive charges that make up carbon, then there are 6 negative charges to make up carbon. That tells us that there are 6 electrons in this carbon atom. Let's mark that. So I'm going to drag over a little box to show this in. Okay, here's my box. And so far we've figured out that for carbon, there are 6 positive charges, and we know this because of the atomic number. And we also know that because this element is being shown on the periodic table, the charges are balanced. So if there's 6 positive charges, there have to also be 6 negative charges. All right, before we go, let's take a look at one more part of this atom mystery. We're going to start looking at where these particles go when they make up an atom. So we have these 2 rings on our screen. This first ring is an inner orbital. So these rings have a couple of names. One name for them is orbital. Another name for them is energy level. Another name for them is shell. And the reason why they have so many names is because different chemists discovered the same thing and they each gave them a different name. So all of these names are used to mean the same thing. So let's put this atom together. First, I put the periodic table box on our screen, and we know that there are 6 protons because we read the atomic number, and it tells us how many there should be. And we're going to put these protons for the positive charge in this nucleus. Remember, a nucleus with an atom tells us that it's the center. This is different from the nucleus of a cell, which protects DNA. All right, so here are our protons in the nucleus. And now we also know that because it's electrically balanced, there are 6 electrons. And these electrons go on these shells, these energy levels, or these orbitals. But there's a rule. We're not going to talk about the rule today, but I want you to know the first part of the rule. The first part of the rule says that the first orbital, or energy level, or shell, can only hold 2 electrons. That's because their like charges repel each other, and there's only enough space for 2 of them to fit in this area. So, if we do a little subtraction here, if we have to have 6 total electrons and we only have 2 shown, that means our other 4 have to go on this next orbital. So we'll put our remaining electrons on this next orbital. Okay. And it doesn't really matter exactly how I line them up here. Right? In reality, they move around in this space. Okay. So here's our diagram of carbon. We have 6 protons in our nucleus with our positive charge, and we have 6 electrons in our orbitals, also known as our energy levels or our shells. Okay. And they have a negative charge. All right, now you have a couple practice problems to work on. Good luck, and check the next video to check your answers and see the solutions for your practice problems. Bye.